Today, class, you're going to be working on the 5.4 notes. So if you could turn to the next page in your pink packet, you will see at the top of the page, it looks like 5.4 continuously compounding. It was meant to be a Desmos activity, but we're just going to walk through the pages and kind of do the examples together. You can see at first you have the situation with the $1 bill. It says you need $1 right now. You agree to pay 100% interest on your loan for 1 year. This is high interest rate, and depending on how often it compounds, you might wind up owing even more than $2 at the end of the year. For example, if the interest compounds twice a year, you will owe $2.25 at the end of the year. What is the most you think you will end up owing over the course of the year? Okay, so pause the video, and you are just going to make a guess as to which one you think it is. Now that you've kind of thought about the scenario, we're going to try using a formula we've used before, which is the compound interest formula. It looks like this: A equals P times 1 plus R over N to the NT, using that scenario. So in every example for the next 4, you just have it listed 1, 2, 3, 4. We borrowed $1 at 100% interest. What's going to change is how often it's compounded. Year number 1 says that it's compounded quarterly. So if I plug in this information, I would get A equals P is the amount invested, which is $1, times 1 plus R is my interest rate. Since it's 100%, that is a decimal, is 1, over N, remember, is number of times per year. So since it's quarterly, it's over 4 to the 4 times. And again, you are borrowing it for 1 year. So it's a very simplistic formula. When I type this into my calculator, I got 2.44141. So if the interest is compounded quarterly in this situation, I would have about $2.44. So that's what you would fill in the blank that says 1 quarterly, and then it has the blank. Okay. So the second one on your sheet says monthly, so that's this example. The only thing that's going to change from the last example is the end. I still have A equals $1 was invested, 1 plus the interest rate was 100, so it's 1 over. But again, now my N is going to be 12, because monthly is 12 times per year, 12 times 1. Again, I type this into my calculator. I got 2.61304. So under number 2, where it says monthly, your answer would be $2.61. Now you'll notice I'm going fast through this, but that's because this chapter and this lesson, we're actually not doing compound interest. We're actually using this idea to build something. So really the most important thing is that you're getting these values down on the list. Next, it wants me to compound it even more. This time we're compounding weekly, so 52 times a year. So I did 1 times 1 plus 1 over 52 times 52, to the 52 times 1 power. When I did that, I got 2.6926. So under blank 3, where it says weekly, you should fill in that this would get you $2.69. And last but not least, they want you to have the interest compounded daily. So 365 times a year. So I do 1 times 1 plus 1 over 365 to the 365 times 1. When I plug that in, I got 2.71457. So it's about $2.71. So again, that would be under 4. So now you have those 4 blanks filled in nice and neatly. I'm going to show you on this next slide, and you'll see here too. But this is virtually what we just found out. Okay? So this is what you filled in on that table. We told you originally that at 1 it'd be 2, so that's why this dot is here. Then they graphed them. 2 times a year was 225. 4 times a year was 244, so on and so forth. So we want to look at this, and we want to think about what we're noticing about the data. And then finally, 365 is over here. I trace this data as x goes to infinity, which is what this is saying. What do you notice is happening to this graph? And hopefully what you're saying is it appears to be leveling off. it does not seem to be increasing much, if any, as this graph goes on over time. And that is, in fact, the case. What we're looking at here is continuously compounding. So up until today, we've looked at compounded a certain number of times per year, even if it's daily. But as you can read on this slide, continuously compounding interest means that your interest is compounding not just monthly or weekly or daily, but every instant of every day. As you can see from the data, there is a limit to how much you can owe, even if your interest compounds continuously. This limit is a very special number called E. Okay, so when you see this E, this is important. You need to know that it is a number. Kind of like pi. When you see pi, hopefully you're thinking 3.14. E is another number. It's short for Euler, a famous mathematician who is shown at the left. E is 2.718282 and keeps going on forever. The key is, though, you don't need to memorize that number. Your calculator has an E button. So now that we know that this E exists, now we are going to make sure we understand the compound interest formula. So if you are ever given a problem and it says that the interest is compounded continuously, you are going to use what we call the PERT formula. A equals P times E to the exponent RT. Some key things that you want to make sure you pay attention to. Again, the word problem would need to say continuously in order to use PERT. The PE are multiplied times each other, but the RT is an exponent. Okay, so make sure, what happened there? Make sure you know that the R times T is in the exponent. Now, one thing that's unique about this formula versus the other one that tends to confuse people, P is the amount invested, okay, or the amount of the loan. E, remember, is just a number. You're going to find that on your calculator. Hopefully you guys can work together to do that. R is the interest rate as a decimal. You do not add 1. A lot of times students will do that. You literally just put it in as the decimal. And T is the numbers of years. So again, usually we refer to this formula as PERT, but you have to remember that the RT is an exponent. If you go to the next page, we can see an example of how we use this. So there's a couple of examples and a summary. At the top of the next page, you see this example. It is multiple choice, so I do want you to pause it and see if you can get it. Once you're done, unpause it, and I will show you the work. So this one just says use A equals PE to the R times T to calculate the amount you owe if you borrow $12,000 for 5 years at a 7% interest compounded continuously. Again, even if they didn't tell me to use PERT, I would use it because it says continuously. Okay? Now, I borrow $1,200, so that's my P. E just stays in my function. R, remember, is my interest rate, but as a decimal, 7% is 0.07 times T, which is 5 years. When I'm done with this, I will try to pull up my calculator and show you how to type these into your calculator. But for now, we just need to know that when I type this in, I was able to get $1,702.88. So you should have gotten this answer. If you weren't able to do that, try to check with a neighbor around you and see if they understand how to type it in. Okay, I want you to pause again and try this next example by yourself, and then unpause it, and we'll go through it. So again, it says to use PERT. Usually that wouldn't be in there. It would just say, calculate the amount you owe if you borrow $12,000 at 4.5% interest, 30 years, compounded. And again, as soon as I see that word continuously, I know I'm using PE to the R times T. I substitute what I know, 120,000 this time. E stays 4.5%. If I convert that to a decimal, remember I move it 2 places to the left, so 0.045, and then T is 30. And it's important I know how to type that into my calculator. And when I do, I got 462,800. Okay, before we summarize, just another side note. I believe this could come up in your homework. If you were once again asked to solve for like the number of years that you owe $60,000 in this example, you would still solve it using your graphing calculator. So if you're given the final amount, you would set it equal to that, divide by the p-value that we talked about with just regular exponential functions, and then you would graph y equals whatever the number is, and then under y2, you would graph e to the 0.045x. So we are still able to solve for exponents using PERT. Just make sure you type an x in for the t. All right, to summarize what we talked about, I can calculate continuously compounding interest using PERT. So you should make sure the equation is written in your notes and that you know what everything stands for. And you can see it below. I know we have it here, but make sure you have it. A is the amount of interest, P is the initial amount, R is the interest rate as a decimal, T is the number of years, and again, remember, P is just a number. So before I sign off, I'm going to see if I have my graphing calculator pulled up here. I'm going to discard this, and let's see. I do have my calculator. So just to review where you go, new document. I'm going to not save. I'm just going to add a calculator. Again, for example, the first thing we typed in was 1200 each. And then the E button, as you can see, it's over here on the far right. Yes, it's highlighted in red right now in case you can't see it. And you can see then in my function, it gives me an E, and then the exponent box pops up. So I would just do 0.07 times 5. Now you can see how I got the $1,702.88. The next example was 120,000. So then I hit that E button, and then we did 0.045 times 30 years. And you can see that's how I got the $462,891. So that's how you can type those into your calculator. And again, just remember you could also use the graphing function if you were going to solve for the exponent, just like we did in section 1 and section 2. That's all we have for this lesson. You should now work on your section 4 homework. And once you finish that, finish up anything else you have from sections 1 through 3. On Monday, we will review. Okay, so thank you and have a great weekend.